2. Question 2. Karen's investigating osmosis using potato cylinders. She's used 6 concentrations of sugar, measured in grams per cubic decimetre. And she goes from 0 grams per cubic decimetre, which is pure water with no sugar added, up to 100 grams per cubic decimetre. 80 and 100 have not been plotted, so these are the two you have to plot accurately on your paper, and you'll be given marks if they're correctly plotted to within plus or minus 1 scale division, so it's good to be accurate with a sharp pencil. The next point's available for drawing the line of best fit, and it should be done like this. So your plots are connected up, and this allows you to interpret what's happening to the potato at the beginning of the experiment. So basically she's got sugar solution of a range of concentrations. Here with 0 sugar added to the water, so it's pure water, the potato cylinders have got bigger. So at this point they've increased by about 6%. So they've increased and got longer because of the cells are taking on water. The potato cylinders have increased in length as more water moves into the cells by osmosis than exits. Water's moving in and out, but on average it's moving more in than out. Down at the other extreme, at 100 grams per cubic decimetre of sugar added to the solution, the potato cells here shown, the cylinders shown as a yellow rectangle, have got smaller. This is because on average the cells are losing water faster than they're gaining water. So water's moving in and out, but on average it's being drawn out of the cells into the sugar solution, so the cells have got shorter. And what you're then expected to work out down here is what is the concentration inside the potato cells at the start of experiment, and you justify your answer. Well, if you've drawn your line of best fit correctly, it should cross the x-axis exactly at the point where the concentration of the water and the sugar was the same as the surroundings inside the potato and outside the potato. And this is because when the potato cylinders don't change length after 60 minutes, that shows that no osmosis is occurring, because the wateriness of the potato cells was exactly the same as the wateriness of the surrounding solution. So you got 1 mark for saying what concentration of sugar from your own graph, depending on where your line of best fit was, where it crossed the x-axis, and you get another mark for explaining that the lack of percentage change in length, the fact that it didn't get bigger or smaller, was because no osmosis was happening at that concentration. The last part of the question asks you to explain how Karen could improve her experiment to increase confidence in the conclusion. Well, if you look back to how many potato cylinders she only used 6 potato cylinders and only 6 concentrations. So any of these would give you marks. If you said that she could repeat the experiment, either by doing the whole thing again with some fresh potato, or using more cylinders in each of her concentrations at the beginning, that would be a good improvement. She could make sure that the cylinders were all from the same potato to make sure it's as repeatable as possible. She didn't say where she got them from, but you could state that if you were to improve it. She could use a range of concentrations, was more detailed, so she went 0, 20, 40, 60, 80, 100, but if she'd had 0, 10, 20, 30, 40 and so on, she'd have had a finer divisions on her graph. She'd have had more points to show her line of best fit, and she could have got an average if she had more potato cylinders. So all of these are good improvements to state, and if you also said why each one of them would increase the repeatability of the experiment, that would also give you another mark.